Hello everybody, I am Krishna Rao Patro. Today I will discuss about one important concept of thread, that is thread synchronization. How synchronization concept can be applied in a thread environment. In a multi-threaded environment, whenever you want to use a common resource, then you need the concept of synchronization. Then you have to know what is synchronization and what is the advantage of synchronization and what is that. Synchronization in Java is a process that allows only one thread at a particular time to complete a given task entirely. So, if there is a common resource area, that resource area may have some set of statement. That one can be executed by only one task at a time, but not all. In a program, there may be multiple thread. If all thread wants to execute a set of statement in a sequential pattern, then other thread has to wait until one thread has to finish. So to make this process in a systematic way, then you have to go for synchronization. So in a simple form I can say synchronization in Java is a process that allows only one thread at a particular time to complete a given task entirely. Okay. Generally, by default, the JVM gives control to all threads, because in a program there may be multiple threads. So if you are not doing any synchronization, then all thread will try to access all the resources at a time. So there may not be any systematic completion. So to control the resource in a systematic way, you need the concept of synchronization. So by default, the JVM gives control to all threads present in the given system to access the shared resource. So due to which the system approaches the race condition, because all are trying to access the same thing. So there might be a haphazard order. So to overcome this haphazard order or race condition, you have to go for synchronization. Synchronization mainly used to prevent thread interference as well as to prevent the consistency problem. There are two types of synchronization. One is process synchronization, second is thread synchronization. One is process synchronization, second is thread synchronization. Generally, process synchronization is used in a multi-processing environment. Assume process P1, process P2, process P3, all are running, and there is a common resource. That resource may be utilized by P1, may be utilized by P2, or maybe utilize P3. So whenever there is a common resource and multiple process, but same resource wants to utilize by all the process, then in that case also you need synchronization. That type of synchronization is called process synchronization. So if you are doing process synchronization, automatically once one process uses this synchronization, means this resource, then other process has to wait until the complete resource is utilized by the process P1. Other process has to wait. If this process comes out, then second process can utilize the resource. As long as the first process is using the resource, second process and third process cannot use. They have to wait until the first process completes the resource. Similarly, there is one more synchronization called thread synchronization. Thread synchronization means what? In a single program, there may be multiple threads. T1, T2, T3. This is a process P. In a single process, you may have multiple threads also. When there are multiple threads, there may be a common resource. This resource may be utilized by T1, T2 and T3. So here, I can control which thread can use and which thread has to wait. So once the T1 gets chance to utilize the resource, the T2 and T3 they have to wait. Once T1 completes, it has to send a signal. Yes, I have completed the task. In this way, I can do in a systematic manner to utilize the resource. So whenever you want to utilize the resource in a systematic way, then you can go for synchronization concept. So in a single process, you can have multiple thread also. In a multiple thread, there will be a common resource that may be utilized by multiple threads. There are two types of thread synchronization. One is mutually exclusive, second is cooperation. That means mutually exclusive means what? Assume I told you there is a resource R and thread T1 and thread T2. Both wants to utilize the resource. If it is mutually exclusive, the meaning is at a time only one can use. If T1 is using the resource R, T2 has to wait. Once T1 comes out, then T2 can enter into that. Once T2 comes out, then T1 can utilize. That means at a time only one threads are allowed to utilize the resource. That is called mutually exclusive. If one is there, other has to wait. Similarly, there is one more type is called cooperation. Cooperation means there must be some mutual understanding. Yes, T1 can use for some 1 minute. After 1 minute, then T2 can go there. Again, T2 can use for 1 minute. Again, T1 can go there. Again, 1 minute. Again, T1 can come for 1 minute. That means, assume to utilize the resource, it may take 5 minutes. Assume. So, instead of consuming complete 5 minutes for me, I will allow other thread to use. That means there will be a cooperation between them. So, I need not wait complete 5 minutes to finish your job. So, in a certain situation where T1 can do some part of time, then come out, then T2 can go and wait for some time, then T1 can go. So, between them, there must be mutual understanding. That type of technique is called inter-thread communication. So, the IPC uses cooperation technique. So, this is also one type of synchronization concept in thread. So, you can implement synchronization by two ways. One is mutually exclusive, second is cooperation. Generally, in IPC or inter-thread communication, ITC uses cooperative way. So, in both the way, you can implement thread synchronization. First, we will see mutual exclusive. The mutual exclusive helps in thread. So, keep thread from interfering with one another while sharing the data. While sharing data, it will keep other thread outside. Other thread has to wait until the first thread completes. It can be achieved by using the following three ways. You can achieve the mutual exclusive by synchronized method, synchronized block, or static synchronization. There are three ways. There are three ways. Okay. So please remember, mutual exclusive you can implement using synchronized method, synchronized block, or static synchronization. So now we'll see one by one. So please remember, whenever you want to have thread synchronization, you can follow either mutual exclusive or cooperative way. Again, under mutual exclusive, you can follow either first one or second one or third one. First one is by using synchronization method. Second one, synchronized block. Third one, synchronized method. Static synchronization. So you can use any other technique to implement mutually exclusive. Mutually exclusive says that if one thread is using the resource, other thread has to wait. That is the nature. Once that fellow comes, then second fellow who is waiting, that can go and use the resource. So that means both cannot use the resource at a time. First, in this thread synchronization, actually internally there is a concept called locking. Synchronization is built around internal security mechanism known as a lock, or also called monitor, or also known as semaphore. So using this locking mechanism, this implements. Once one thread goes into the resource area, that resource area is under the critical region. Under the critical region. Once it goes to the critical region, then that will get the lock. Once the lock is obtained, then nobody can enter unless you unlock. So to get the lock, then means to have the lock facility, you should have a concept called synchronization. The synchronization concept internally implemented with the help of locking concept. Synchronization is built around internal entity known as lock or monitor, or also known as semaphore. Every object has a lock associated with it. Every object has a lock associated with it. By convention, a thread that needs consistent access to an object's field has to acquire the object's lock before accessing them. Before accessing, you must get the lock. Whoever gets lock, they can use the resource and release the lock when it is done. So whenever your work is there, you should hand over the lock so that other can utilize the resource. So once the lock is retained by you, then the complete resource is under your control. Once you come out, you have to hand over the lock. That means you have to unlock. After unlocking, the other thread who are waiting, they can utilize. Actually, from Java 5 point onwards, the java.util.concurrent.locks, there is a built-in class. There are a lot of classes are available under the concurrent package. It contains several lock implementation. Now we'll see the first technique, synchronized block. How the synchronized block concept can be used to implement their mutual exclusion. Synchronized block can be used to perform synchronization. Synchronized block also can be used to perform synchronization on any specific resource. If at all you are having a resource, that resource can be synchronized. Once it is synchronized, then it is under your control. That means all cannot use at a time. Only one can use, whoever gets the lock. So please remember, synchronized block can be used to perform synchronization on any specific resource of the method. Suppose we have 50 lines of code in our method. Assume there is a method, you are having 50 lines. There are 50 lines. But out of 50, I want to synchronize up few lines, 5 lines to be synchronized. That means these 5 lines should not be accessed by all threads at a time. I will allow only one thread to use, but not all at a time. In that case, I can keep a block. In such case, we can use synchronized block. A block of code I can control. Instead of controlling the entire method, I will set a few lines of the method, because the method may have multiple lines. In this example, I told there are 50 lines in a method, but out of all, I am synchronizing only 5 lines. In that case, you can create a block. In that block, you can keep these 5 lines so that these 5 lines can be synchronized. If you put all the codes of the method in a synchronized block, it will work same as synchronized method. Actually, if you use the complete method under a synchronized area, then the complete method is synchronized. Whereas here, I want to block only few lines of the code, not entire method. So whenever you are forcing only few lines, that is called synchronized block. There are some important points you have to remember. Synchronized block is used to lock an object for any shared resource. Whenever there are common shared resource, there you can use. The scope of synchronization block is smaller than the method. Actually, method having multiple lines, but block having few lines. So a block is a part of method. Block is part of method. The system performance may degrade because slower working of synchronized keyword. Actually, if you use synchronize, what will happen? Other thread has to wait. Even though you are not doing sometime any work, still you have to wait. So in that case, it may degrade. Assume I am going into the critical region, but I am not doing anything. Simply sleeping. In that case, the CPU time will be wasted. In that case, you will get problem, degradation problem. Java synchronized block is more efficient than Java synchronized method. Java synchronized block is more efficient than synchronized method because all statement may not require a very few lines I may need. Then why should I synchronize the entire thing? All can do parallelly also. So in that case, whenever a few lines are important or to be controlled, in that case, the synchronized block concept is better. So this is a point you should know. Please remember these 4 points. Now, we'll see a small program to use the synchronized block concept. Assume I am having a thread T1, a thread T2. There are 2 threads. That thread T1 and T2, they want to use a multiplication table. What table? Multiplication table to print I want to have a multiplication table to print which table? Nth multiplication table. T1, he wants to multiply 5 multiplication table. T2 wants to multiply 100 multiplication table. So now, at a time, either T1 can complete or T2 can complete, but not both. So, for calculating, I need a calculator. I am having a calculator here. In the print table, I am having a calculator. The calculator is doing. Generally, for multiplication table, you need a loop to repeat. So, my table, print table, having a method. This is my calculation part. So, please remember, this is my resource. This resource I want to control. Class table, having a method called print table. In the print table is method, I am passing n as a parameter. There, I am having a block of code. This part, I want to synchronize. There, what I wrote my logic. What logic? I want to multiply my table 1 to up to 5 with for the value n into I. Assume n equal 5. So 5 into 1, 5. 5 into 2, 10. 5 into 3, 15. 5 into 4, 20. 5 into 5, 25. So whatever the value of n I am passing, that corresponding to one I want to print. Even though while calculating, in between I am sleeping. Even though I am sleeping, the other thread has to wait. Because I have entered into a block called synchronized block. So please remember, to create synchronized block, there is a keyword called synchronized. What keyword? Synchronized. This keyword will allow to create a critical region so that all thread, they have to wait once one thread enter into a block. You cannot do your task until that thread comes out. So now, assume I am having a table called, a class called table. In the table class, I am having a method called print table with parameter n. Here, I kept the setup statement in a synchronized block. There, my loop is running. While running, sometimes it is sleeping also. Even though you are sleeping, other thread has to wait. Because it is a synchronized area. Until I come out, it will not do anything. This is, we are mutually exclusive. Mutually exclusive. Now, observe here, I am having two threads. My thread 1 and my thread 2. There are two classes. This thread is my resource in my table. This also thread uses the resource. Both are having right to use the resource. But who can use? Either T1 or T2, but not both. But not both. So, whenever this fellow is getting chance, it has to complete all. So, when I am calling D.T, I will call what? T.printable. This fellow is multiplying 100 and this fellow assume multiplying 5. So, first thread is multiplied with 100, second thread is multiplied with 5. So now, when I am multiplying, either first thread will make a chance or second thread may get chance. So whoever gets chance, he has to complete the task. First 5 table, then 100 table, 5 into 1, 5, 5 into 2, 10, 5 into 3, 15, 5 into 4, 20. After that, then T2 is getting chance. 100 into 1, 100, 100 into 2, 200, 100 into 3, 300, 100 into 4, 400. While doing the task, sometimes you are sleeping also. Because while, I think I have shown you, because T is what? My object. This object is my resource. This is my resource. Okay? This is my resource. This resource having synchronized block. Here, when I am entering into this synchronized block, there I am doing my task. What task? Repetition. While repeating, I am sleeping again 400 milliseconds. So you have to wait. Even though I am sleeping, second thread cannot enter. So that means here CPU is not doing the task. In that case, it may also degrade. But systematic. Until T1 completes, T2 cannot do. Or until T2 enters. Sorry, once T2 enters, T1 cannot do anything. Because who is getting chance, we cannot predict whether T1 or T2. Now, I am having a object called table object. Here in the table object, I am having a method called print table. Print table with n parameter. Once I pass n as a parameter, that will do the task. So who is using this object? This object is utilized by T1 as well as T2 also. So here I am passing this object as a parameter. That means same resource, only one copy of obj is there. Both uses same resource, but only one is allowed to use. I said that you go and use, you go and use. But who will use? So whoever is getting chance, because the system decides, whichever thread is getting chance, that thread can do multiplication. Once I say start, both are ready to run. That go to ready state. Ready to run. Okay. Let us see how it works. Now we'll try to execute it. I'll go to my program. Control N. Here, first of all, I have to create the resource. First is resource. My resource is the table class. This resource wants to utilize by both thread T1 and T2. Class table. This is a normal class. Okay. This class, what it will do? It will do the calculation. Now I am having a method called void print table, and I am passing int n as a parameter. Whatever the n you are giving, to that n it has to do the multiplication table. Now here what I am doing, I will, because the entire method I am not doing synchronized, because we are following synchronized block, a part of the method. So I am using synchronized block. Synchronized block. Synchronized block. Here what I will do, I will use synchronize. There is a keyword called synchronize. This portion. Here I will be using what? My logic. I will use my logic for int I equal to 1, because I want to have multiplication table. Multiplication table start from 1 until assume I less than equal to 10 I will put. I want to multiply up to 10. I plus plus. Now whatever the value I am passing, how much value I am passing, that is there in n. So this n I want to multiply. System dot out dot println n into I, n plus into that symbol I want to print, plus I equal to n into I. N into I. Now this loop repeats. How many times? 10 times. But in between it may sleep also. Assume I may say sleep for some time. Even though you are sleeping, other thread cannot disturb you. Try catch exception E. Here if at all somebody disturb you, so now what I am doing, after printing I will sleep. Thread dot sleep. In thread class there is a method called sleep method. Sleep for assume on 2000 millisecond. This is in terms of millisecond. That means 2000 millisecond means how much? 2 seconds. Equivalent to 2 seconds. 2000 millisecond is equal to 2 seconds. Now, even though it is sleeping, other thread cannot enter. If at all somebody disturbs, there may be some exception. System dot out dot println the error. the interrupted exception error. That error I will print it. So now this loop repeats from here to here. It is going from 1 to 10. Then my synchronized block starts here, it ends here. In between, you can write some statement also here. Because it's a synchronized block. Synchronized block means you are blocking a portion, not entire code. So if at all you want to write, you can write also. Write remaining code. Write remaining code. Okay. Now this table is acting as my resource. This resource I want to utilize in my other thread. So I'll write class my thread. Assume my thread 1 is a class. If you want to make this as a thread, how to make this as a thread? I told you in the previous session, you can create thread by two ways. Either by extending thread class or by implementing runnable interface. Let us extend thread. Extends thread. Once I extend, then that will be thread. Now, my thread, I am passing one table object, table obj. Okay. This thread means my table is a reference TBL. Whatever the object I am passing, that become a table. Which table? My multiplication table. Table obj. Now, using this, I can do it. Because that is a thread class. In thread class, the main part is run method. So I'll write main method. Public void run. Here I will write my logic. Here what I'll do, I will call my table dot here I am passing comma okay, here I will call print table, sorry, my print table with I am passing 5 as a parameter. Okay, that means I am calling print table method with 5 as a parameter. This is my first thread. Second thread, Control C, Control V. I am creating two thread. My thread 2. This is thread 1. My thread 1. This is my thread 2. Here also I am having table, passing this one, and here I am multiplying with 100. First thread is doing 50 multiplication table. Second thread is doing 100 multiplication table. Okay. Now my driver code. Go to synchronization demo. Sync block demo. This is my program. Public static void main string argument array. Here what I will do, first of all I will create an object of the resource. Which is the resource? My table is the resource. Table is the resource. T is the object. This equal to new table. This table object I will be using in my both the thread. Which thread? My thread 1 and my thread 2. So my thread 1, it is one th1 first thread. This equal to new my thread 1, and I will create one more thread. Control C, Control V, my thread 2. That means I am creating object of first thread and second thread. th1 is the object of my thread 1, th2 is the object of my thread 2. But both will be using the resource. This is my resource. T is the resource. This T I will be passing here as well as here. You are having only one copy. One copy of the resource is there. But you are giving to both the object. So That means what? There must be mutual understanding between the two threads. If first thread is using, second thread has to wait. If second thread is using, first thread has to wait. So for that, you should use synchronization concept. So already you made it synchronize. Yeah. So my thread resource is synchronized block. This block will allow only one thread, even though you are given to both the thread, but both cannot use at a time. Now let us run it. Sync block. Control C, Control S, Control V. Here. Now, please observe here. Control S, Control V. What is the problem? If I run the program, what type of output will get? Because you have not started whether it will work or not. The thread is not yet started because once you say start, then only it will run. Now I'll show you Java C sync demo. Yes. Now there is an error, line number 27, semicolon missing. Yeah. Semicolon missing. Semicolon missing. Yes. Yeah, now no problem. Now Java synchronization demo. Sync block demo. Sync block demo. Yeah. Now you are not getting anything because both threads still on in the bomb state. It has not gone to ready state. So to make it ready state, you should call th1.start. th1.start. th2.start. Now let us compile. Yes, compile. Now run synchrondem. Yeah, now first thread gets chance. Now see, still in between there is a sleep condition. Even though sleeping, other thread is not interrupting because there is a mutual understanding, mutual exclusive. Until the 5 completes, the 100 will not go. Now, yeah, now you got the second thread chance. Now just keep on running. It will continue until 10th time. So, whenever you want to control this type of resource, then you can use the mutually exclusive concept. I hope it is clear. So, you can print also which thread is doing. While printing, you can print the name of the thread. Once the thread enters here, you can create one name also. My thread followed by some name. th1. Here also you can pass comma th2. Just I have given the name. Here I am passing comma string name. Name is what? The name of thread. I can assign set name the name. That means I am assigning a name to the thread. So now I am going to this method, and here when I enter here, I will print the name of the thread. System dot out dot println get name. I can print the name of the thread also. Control C. Get name. Now let us run. Yes. Get name is a method. Method means you should write as method. Yes. The name of the thread. my thread followed by string name. Here I can assign set name, compile. Yes. Now Java sync demo. Yes, I got the name of thread name on thread 2. Okay. So now once the thread enters into the block, it is keep on running until it has to complete the 10 times, because the loop repeats 10 times. After repeating 10 times, the second thread is getting chance. Okay. Now 7, 8, continue, 9, and then 10. Then it will stop. Here you are calling what? Table dot printable. No, you cannot call here. The value of n we are passing. While calling printable, you can pass the name printable followed by the name. I am passing the name. Control C. Which thread is running? I can pass comma get name. Okay. Here I will put comment because I want to know which thread is running. Get name I am passing here, comma get name. So I am passing the get name. This get name goes to my method, comma string the name. That name I want to print because which thread has entered into the block. I want to check which thread has entered into the block. Let us check. Because my goal is to find out which thread is entering. Yes, compile. Now run. Yes, now thread 1 is getting chance. Of course, please remember, you cannot give guarantee which thread is getting chance, whether first one or second one. Now, in this case, the T1 is getting chance. Now, after completing 10 times, then the T2 is getting chance. See, after every time, it is sleeping for 2 seconds. Now T2 has entered. So this is the way you can do your synchronizer program. So in the next session, we'll see the second technique, how to use the synchronize method. Now you use synchronize block. So see you in the next session.
Like, share and subscribe. Hit the bell icon for more updates.